Okay, so I had a few technical issues. I lost the internet, and then no computer would work in the house for some reason. And then my laptop wouldn't charge this morning, so I'm a bit slow getting off. But here we are on area and volume, text and test 6, section 6.3. I'm going to run through the examples, and then I'm going to do the odds. So I'm going to just do a quick example on the first two videos. A quick note, just a bit of junior cert revision about a prism when we do come across a prism. So there's kind of, I suppose when I'm talking about a prism, everything that's three-dimensional is a prism, but when I'm talking about a prism, I'm talking about something that has a fixed cross-section. What do I mean by a fixed cross-section? So if I have a look and I have a triangle, for example, and I turn that into a Toblerone. Okay, that is a fixed prism, because when I start cutting, if I get a knife and I slice through my Toblerone and I look at it from this side, I'll see the exact same shape every single time. So if I just find the area of the front, if I find the area of the front shape, whatever that is, and then multiply it by the length, the volume is just equal to the cross-sectional area, the area of the front, multiplied by the length. Okay, so that's why, where have we seen that? We've actually seen that before in a cylinder. So for example, if I have a circle, it's pi r squared. I'll write it in there, area equals pi r squared. Now if I turn that into a prism, it forms a cylinder, and the length of my cylinder, I just refer to my height. So the curved area, or sorry, the volume of a cylinder, apologies, the volume is just the cross-sectional area, pi r squared, multiplied by the length, which in this case is h. So that's what I mean by a prism. What is not a prism? Well, I suppose if I was to take a shape like a parallelogram, now if I was just to extend that back as normal, yeah, that would be a prism. But what if it wasn't going straight back? What if it was going down and getting smaller? So it's actually getting smaller as we go towards the back. Terrible drawing, I'm sorry. So it's getting smaller. So when I cut it into pieces, yes, I still get this, sorry, not parallelogram, I still get this trapezium, but it's getting smaller and smaller. So it doesn't have a fixed cross-sectional area. So that's just a quick note of what I mean when I say prism. Now, let's have a look at this here. Find the volume of a truncated cone, which is known as a frustrum, correct to 1 decimal place. Well, if we have a quick look at page 11 on our book of our tables, we see the formula here for the area of for the volume or area. Crikey, I'm sorry, I'm very asleep today. Volume, apologies. For the volume of a frustrum. So it's 1/3 pi h r squared plus r plus r squared. So big R's and small R's. Big R's stand for the bottom radius. Small r is the top radius. L is obviously my length and h is my height. So let's apply that formula in this case. So we got pi h r squared plus r. So the big R is obviously this, my small r is this, and my h is that. So the volume of this guy here is equal to, sorry, coffee is falling over. Volume is equal to, and I've forgotten my, sorry, very slow today. It is pi h r squared plus r plus r squared. 1/3 pi h, 1/3 pi h, 1/3 pi h r squared plus r h r plus, sorry, r squared. Okay, so volume equals 1/3 pi, h is 8, big R is 6, big R is 6, small r is 4, and small r is 4. And all that goes into our calculator, and we get 636, and it is centimeters, and it's volume, so it is cubed.